that the validator would be this. So this is how it works now. Let me go to the next slide. Yeah, so this is like the core of a validator kind of a thing, uh, where right from here TPU. So TPU is where the transaction processing will take place. This is inside a validator. This is called processing unit TPU. TPU forward would be like if this validator, let's say it is not able to validate all the transactions which came in this slot, then it will forward it to whichever is the next leader uh, going forward, and vote will be like the voting transactions, which will be the like confirmation that from everyone that like the consensus mechanism of votes. So, and yeah, like you may know about this whole controversy that Solana counts normal, like voting transaction also has normal transactions when it counts TPS. So here it is, like why? Because these three go to the same place in the validator. So there is not much, like in the code, there is not much difference between this kind of thing and this kind of thing, except the voting transactions have some loss protection, like so nobody can just spam voting transactions for to a validator. So these are the three things which goes in. Now then there is a signature verify, like we verify if like this took place properly or not. Whatever transaction is coming in, is it signature is well or not? And this is the meat, which is the banking stage. Here is where all the logic is run and everything is done. And like I can show you the code itself. That will be great. So yeah, this is the sig verify stage which you talked about, and yeah, this you can see this. It goes to a curve which is ED 25519. This is very famous, I think, which verifies the signature. So this is the stage which we're talking about. This thing. Then next will be the TPU. Like wait, next will be banking stage. Yeah, right. So this is the banking stage which occurs, and there should be a different file for it. But
I think
yeah,
it's called bank.rs somewhere, right?
yeah, it was there. I'm not. Yeah, banking stage. So this is where all the logic is run, and like uh, the meat of the validator is here. Next, it goes to the POH recorder. So it will be something like uh, for every transaction, the data of the transactions along with the slot is all recorded as a POH record. It's a timestamp. So I can show you a pseudo code this guys have written. Yeah. So you see this. This is the POH service, uh, where this is the output and it will get hashed. And this is a VDF, is verifiable delay function. So we can say that when this hash came in, based on the output. So we can say that this was first, this was second, this was third. And in actuality, it works something like this. There will be a record queue where if the record comes in, like record is transaction. If the transaction comes in, which is like this, it goes up, then it will hash it, and otherwise it will be an empty, just a hash without transaction data. And next, so yeah, another thing I think we discussed this last session as well, that in Solana transactions are constantly streaming. Those are the mechanism is called turbine, and the stream transactions are, I think they are 64 KB in size or 120. I'm not sure, but those are then shredded. Like uh, in general, what happens is the whole block is built by a leader, and that the whole block is pushed to everyone. In Solana, instead, it is constantly streamed. Like as you can say, out of a huge block, some there are like 2,000, 3,000. It is divided into 2,000, 3,000 parts, and it is constantly streamed. And individual parts are called threads. So it helps in decreasing the load at like a one-time burst. This validator has to do, and it also we can utilize the resources of other validators. Like when it is streamed to other validators, they will stream it to other validators. So this guy will be connected to multiple validators. It will be like a tree kind of a structure, and those will be connected to many more validators and stream like that. So here is the TPU now. Coming back to Firedancer.
But in turbine lock propagation, they stream it to all nodes, right? Because
Yeah,
in Gossip, like
yeah,
they
yeah,
used to give it to the other nodes and then they used to pass it on.
yeah, yeah, like this, right? Leader will stream it to the nearby validators, then validators will stream it to more nodes, and
Oh,
then
okay,
new
okay,
ones,
huh.
right?
Yeah, yeah,
Yeah,
got it.
this is turbine. So tree like structure, and now yeah, let's come back to Firedancer. Yeah. So what they aim to do is so Jump comes from a trading background. So what they told us in the talk is they see this as a kind of a like we have exchanges, right, like Nasdaq or stuff like that, which constantly gets this trading orders, like buy this, bid this, sell this, limit orders and stuff like that. So this sees Solana something like that, where there is constant packet ingress, then there is runtime, and then there is consensus, and this is replay and capture, and which handles all the other complexities. Now, what they plan to do, how they plan to progress is they will replace each one of these components one by one. So, first component will be the packet ingress, and that's what they were talking about right now. And this is like, and they're calling it Frankendancer, this one component, and you can think of it like in the like there will be an upgrade where this component will be built by Jump, and other two will be the Solana native components, which will be rewritten in C and C++. So that is also one more thing that we want language diversity just to avoid any bugs. So there will be two separate clients, but it will like Jump will approach it component wise. So now coming back to our TPU design, so I think this is my guess. We are only talking about this stage, uh, like kind of this stuff right now. They have not reached banking stage. Banking stage is the processor unit. So they have still not reached the runtime and consensus or anywhere else. We are at this stage, like you fetch it and you verify, signature verify. These things were talked about. Uh, and also one more caveat is these things have changed because this is all made with UDP in mind, but now it is shifted to Quick with recent update. So this there may be changes over here as well. But we can say now, yeah. So we are talking about this packet ingress part. Runtime, I think they will talk later. So let's go there. Uh, yeah. So this is how they see like all the like just people flooding the nicks and transition coming in, and this they have divided everything in a tile-based structure where sig verify will be the next tile, deduplication will be a tile, and finally a packet will be ingressed to the Solana runtime, which we saw in the last slide. Uh, so now going into detail about this individual parts, yeah. So if anyone wants to know about like where this is in the GitHub repo of Firedancer, then you can say that yeah, this is the Frank app, this is the Tango image, something like that. I can show you.
Yeah, I think they have folders
Uh,
for each of those.
yeah, yeah. So it's very easy. Yeah, see Tango and stuff like that. So Disco and so if you want to go and check, yeah, you can check it out. And after that, yeah. Yeah, this is the inside the tile now. Deduplication, as the name suggests, you have many duplicates. So generally, you cut it by half. So in the talk, they were getting some 1.2 million transactions per second, and they were cutting it to 0.6 million transactions per second in this dedupe tile. And next is the stick verify tile. I think what we saw in the REST client. This part is the so one thing with interesting thing which they also talked about was Amdahl's law. So what Amdahl's law largely means that when you have a large piece of code with multiple programs working on multiple type of instructions, and you want to speed up through parallelization, uh, there can be a bottleneck in a single instruction set which cannot be parallelized. So ideally, what you want is each and every step should be somehow parallelizable in order to not have that bottleneck. So that is one of their main focus when they are working with uh, uh, working on a new client.
Wait.
So
Could you
yeah,
like explain a bit more about that law? So how is each part slow?
So, Anush, I'll just add something over here because we experienced this when I was at Goldman. Assume that you have all sig verify parallel, and then you have one synchronous call, which is the call, right? Till the DB call cannot happen, whatever parallelism you gained in the previous layer is gone because you have to wait on the DB call.
Okay,
So
yeah,
it essentially says that you are limited by the sequential processing in your entire program.
yeah. So
So
either
if you
either
have
like completely parallelize it or don't, right?
technically yes, the whole idea, yeah. If it is not completely parallel, whatever is the sequential part, you just get blocked
yeah,
over
it
there.
is about that. Yeah.
Okay, okay, yeah. Got it.
So yeah, thank you. So this is one of their bottlenecks, and so then there were two, like this talk then went to like the presentation part where they uh, handled all the stages, the deed up stage, this the sig verify stage and everything. That was a presentation which they gave. Now after that they went a level deeper. Like there were two more things which they were working on. One was about uh, this kind of optimizing the uh, SHA-512 calculation, uh, which they like. It is in the sig verify part because that is one of the core of any kind of validator. Like you have to verify large amount of signatures, right from even not only the transaction signature which you have know of. You need to have that voting signatures. You need to verify them, and there is constant like I forgot the numbers, but there is constant flow of like you need large number of signature verify, and you somehow need to optimize for that. So then there was a talk about how they do it, uh, how they optimize signature verification through hardware acceleration and other stuff. And the third one was about block packing, how to efficiently do block packing. So something like this. Currently on the left side, as you can see, uh, uh, so uh, how it works is, let's say you are the leader, right? Now, one thing you can do is you can get in maximum amount of transactions what you get in a single block just to maximize your you are getting paid on the transaction fees, right? So you want to maximize that and get it. But it may happen that other validators may not be handle this kind of load at a time, and the consensus may decide to drop, right? And at the same time, if you go lower, like if you do a very conservative approach to block packing and say, okay, I don't want to do this kind of a zero something where I get nothing or I get a lot of transaction fees. If you do conservative packing, then obviously you miss out on a lot of transaction fees and stuff like that. And most of the validators opt in for conservative packing. And you can see over here, like the prediction compute unit and the actual unit, there is a huge difference. So ideally, this should be like straight line, but you can see there is a huge difference. Now
What
the
is the
Firedancer
prediction compute unit here?
uh, like compute unit is the unit through which it decides that how much this particular block will like how much compute it will take. Now, for example, it takes 100 compute units, right? That would be predicted, but in actuality, as I said, as I
Uh,
explained before, it will be way lower because of this kind of
because
dilemmas which they have.
the nodes will decide to drop certain transactions.
Yeah, yeah,
Okay.
not drop forward it to other nodes like
Other one.
you
Okay.
think
Okay.
you
So,
yeah.
Hit, what is block? Like, you could explain a little bit more on block packing also.
Yeah, block packing is simply adding transactions to the block, right?
Hmm.
Yeah. So they optimized somehow. Like I'm not able to understand how they did it, but their R square was 0.89. R square simply denotes like how close the like how close is it to
Yeah.
expire time. Yeah. So
Yes.
how close if you draw a line over here, like how close is it to? And they got it at 0.89.
The R square is
So
the ideal estimate. Like, essentially ideal. How much difference do you have relative to the ideal packing scenario? This is higher, but they haven't given details as to how they pack it, right?
Yeah, so they did. We can go to.
I'm also thinking because the streaming block packing, how so it's like a online algorithm which needs to run for optimum.
Yeah. Uh, so I can go to this part where we talk about. Yeah. So basically, there is a compute unit program, right? Which was recently added. Now, anybody who I have never used it to be honest.
Yeah, the increased compute unit program है yeah.
Yeah. So that was introduced. So when you send a transaction, when you have better estimate of the like the compute unit which you are doing, uh, it will be better at packing, right? But most RPG servers don't use it. It is optional kind of thing. So yeah,
But do they act like because if the compute unit exceeds, it actually just fails the transaction. It doesn't send it to another node. I think.
yeah. It is basically yeah. Basically, you don't get anything out of that,
Yeah.
right? Yeah. So yeah, so this is the third talk which was there by the team, and
So
apart
just one
from
more
that,
question. I just realized something, and thanks both Hate and Ash. So essentially, compared to other clients wherein you have a mempool, wherein you can optimize the blocks because you have so many transactions to choose from, Solana is faster. So the problem statement of optimizing the block is much more complicated because it's like a online query wherein you have to estimate what are the best blocks for the current validator. It's a very different problem statement than I have this set of transactions. I have to pick the optimal so that the block is maximally more better for a validator to mine or validate versus over here wherein the validator is getting streaming blocks and it has to decide that hey, I have to create a block right now which is economically more incentivized for me and they have to select it. You're getting the problem statement which I'm trying to state. There are two different problem statements for
yeah,
Solana versus
yeah,
Ethereum.
yeah.
So like the consensus is like slower than the execution here.
Uh, you can yeah, you can say that actually, but we have not like these people have never talked about consensus itself. So I don't know if they are
Yeah.
considering anything with regards to that. But
It's essentially if you have streaming messages coming in, and now you have to
yeah,
optimize considering that you have streaming. So the algorithm you'll use is very separate from having all the transactions in front of you and selecting the optimal.
yeah,
Right. Right.
It's like ML problems, like recommendation systems in which you're getting messages every minute, or you just look back into previous history and decide what to do. So yeah, very interesting.
yeah. So here are the numbers. I think here in this blog they mentioned the numbers, like how much do they? Yeah, yeah. So the leader needs to transmit 128 MB blocks, but obviously you shred it. You have turbine shreds, So yeah. This is how they do. 2064 KB packets, uh, and it goes like in a tree structure like this. And also, interesting this thing is this is stake weighted. So the validator with the highest stake will be closer to the leader. So neighbor one, neighbor two will be someone with very high stake. So yeah,
Got it.
This is only done because I think UDP packet sizes are max 64 KB. And because the block size is chosen to be 128 MB, you have to transmit 2000 packets to
yeah.
for it to
I
make
think
sense.
this thing will change after quick, right? I think this yeah.
Yeah, with
Quick
quick, yeah, I don't know if 64 KB packets is maybe it is still relevant because this is a very real problem, by the way, because we had the same issue when we were doing it at. So we were also building something similar wherein we had to send these packets Earlier, we were just sending one event per packet, and then we changed the block packing algorithm. Over there was just we just looked at network packing algorithm, and we just increased the number of packets you can do. So the whole problem here is you are limited by the network, and you want to make sure as many packets as many messages can go in one single packet, because otherwise your limiting factor becomes the round trip times.
Correct. Yes.
Yeah,
So we
like
had
you
this whole
don't.
problem that, yeah,
Even in
Yeah,
like database queries, you try to batch the queries and then send them.
exactly, exactly. So how can you batch it becomes the big question over here.
yeah. This like Kevin Bowles said in his talk that I hate batching, but like his point was everything should be parallelized and streamed. I don't know what like how does
That
it.
works if you're in the same data center. That does not work if you're geographically distributed all across the globe.
Yeah, I
So
don't know
so
like
he's
how it
saying
works.
that they don't want to batch, but instead like stream it one by one.
That has happened right now, right? They like the naive approach would be to transfer all this 128 MB blocks to 20,000 validators when it is done, and it's like so. Also, there is an interesting graph which I saw, which was like if you let's say plot compute units of all the validators on x-axis. So let's say there are 2008 points now because there are 2000 validators, and like on the y-axis you have compute units, on the x-axis you have all the validators now. One validator, say 2000 validator. If you look at it, for every slot it would be like one validator will be using the whole of this processor, everything, it will be processing everything, and others will be sitting idle, right? And same way when it is based on it, it is a leader based resource constraint. Like then you have the second validator, which will max out its capacity, and others will be sitting idle. But with this approach, because the person who is the leader is constantly transmitting whatever transactions it is receiving, we can say that every validator at every point of time is using some kind of its network bandwidth by you having this kind of tree structure. At the same time, it is also doing the vote verification, sig verification, and all this stuff which is required to confirm that these transactions are valid and all this stuff. So this is efficient resource utilization compared to this naive approach of letting one person build the whole block and then transfer to everyone.
And just to like clarify, like on when the when the transaction is streamed to the other nodes, they also use their compute units to like verify the signatures again, right?
Yes.
Yeah, yeah.
Right.
That is the point of blockchain.
There's a pipeline mechanism, I think, very nicely put it. Because if you just keep on streaming, the pipeline keeps on chugging. And it's not like one batch is sent to another validator and they validate. So this is exactly like an automobile, when an automobile parts are going through the conveyor belt, and you can just keep on doing work. No one is stopping. And that's why usually the validators are like only 10 or 20 milliseconds behind the leader, which does not happen in most other systems.
Yeah, I was trying to find this talk where they mentioned this problem and how Mr. Nag and Vitsui and the actors are solving it. But it's a pretty interesting thing that Solana got it before everyone else. The streaming part, and it's very difficult to implement.
Yeah, Sui, I don't like. I've also been trying to understand what Sui is doing. They also don't have consensus for all messages.
Yeah,
Uh,
the I think it does make sense.
Yeah,
yes.
that is like they're segregating the like importance of different state. Like even Deso is doing that.
Yeah, I was like, I haven't reached up to that. I don't know how contention is involved over there. But this makes Solana makes very like intuitive sense once you understand the whole that they're optimizing for pipelines, they're optimizing for resource.
yeah, yeah, this one, yeah. So if I go over here, yeah. So yeah, this was the graph I was talking about. If you see, like this is time one, this is slot one, slot two, slot three, and you can see that the leader's resource utilization is maximum, whereas other people are sitting idle, like other validators, they don't have any. So, yeah, and they have Narwhal as a new mempool. Their mempool also does the same thing. It actually kind of streams transactions to other people with like what Solana does and let them process it. So if you see, yeah, it will batch it, uh, and there will be mempool protocol which will transfer it to other validators like that. Round one, round two, and this is a DAG-based protocol, so I think the whole data structure changes in a significant way, something like this. So yeah, this is an interesting part actually. Can watch it.
I just want to understand a bit more like about why the other nodes are like sitting idle in this scenario.
In every scenario, like because one node is doing all the stuff with taking on in all the transactions, verifying it, making a block, and once it is done, it will transfer it to other validators, right? So by during that time, what are other nodes doing?
No, this is in Solana you're saying, right?
No, this is like the naive way of doing stuff.
But then
This
even in
happens in
even in
any.
Solana, like they have one like node just building the block, right?
No, no, it's streaming
It's
also.
it's streaming now. It's streaming to other nodes
Yeah, but so it builds it and then streams it, right? Or like it's doing it simultaneously.
while building.
Oh, okay.
While building.
Okay, okay.
So we saw it over here, right? That yeah, there are 2,000 packets in a single block, which need to be transferred of like 64 KB packets. This may have changed it quick, but yeah,
Okay, okay, yeah, yeah, yeah. Now it makes sense. Yeah, it's good.
So the 2000 buckets are with each validator, and whoever gets it starts taking the shred and processing it and executing it. So by the time it gets the next packet, it's already processed a significant amount of it. So ideally, if you can be really, really fast, the validators can be just behind the leader by the round trip, like half of round trip latency time. So they'll just move in locks, which is amazing.
yeah, it's
Yeah.
kind of like it is obvious with when you see this graph, and it is so simple, but it makes sense. Like to utilize all the resources efficiently. And also, it solves the network bottleneck problem where you're not throwing like this large blocks to 2,000 validator at a single time.
So like uh, now you have to kind of make a decision between reducing your network bottleneck and using the entire network's compute uh, together, right? Because if you batch it, then uh, you're less bottlenecked by the network, but also a lot of nodes are sitting idle. Is that correct?
Yeah, so I can show you the naive approach. I think it is Tendermint.
So Anush, yes and no. You will have to batch it at some level. And the problem is how many transactions you would want to batch. So essentially, it might be that if you make the bucket bigger, let's say I'm going to batch 10,000 transactions, that will make the node sit idle for longer. But at the same time, you can optimize it further because you can just make sure that the best transactions go into the first bucket. Versus if you take a smaller bucket, which is probably like 500 transactions, the resource utilization goes up, but the probability that the 500 first node had more fees, you lose up on that. So it is a trade off. And that's why the whole block packing, how do you pack blocks more efficiently, is what I think they're working on. Does that make sense?
Yeah, so
Yeah,
you're saying that in the full bucket like of 10,000 transactions, they'll send the first like the best like 2,000 transactions first in a batch.
Yes. They will try to. Like, you need some heuristic to do that.
so this is the other approach. This is a naive approach for Tendermint. So let's start over here where the leader proposes a block. First, then it once it is done, it goes for the pre-vote stage. which is like I think it has 150 validators, so it will send it to 149 validators. Whether it this valid block, if it is invalid, then it will need like it won't be there. But if it's a valid block, then it will go. Now the leader is waiting that other people will pre-vote on it. So leader now waits. Okay, whether it got it, then it didn't. This is no condition. So it won't get it. If they just this at this block height, there would be an empty block or there will be another leader. But if they get a pre-vote, then again there is a block. Now again they will wait because now every validator needs confirmation that every other validator confirmed this block. So this will be second stage of messaging with where every validator will get a signature from every other validator on this particular block, and this is called pre-commit. And when once if that is confirmed, then yeah, you commit that block and you have a new height. If it is not, then you go to a new round where there will be another block as well. So this is a naive approach where Tendermint approach, how it works, like how this consensus works.
And just to add, you understand there's going to be a problem over here, right? This cannot be a decentralized network beyond a certain number of nodes.
Yeah, because this network overhead it
Yes.
goes too much. Yeah.
So it becomes order n square, and as soon as you add the next validator, the time to find like the time just keeps on increasing.
Like this has
exponentially.
to go through every single validator.
Yes.
Oh
Yes.
shit. This is
So
terrible.
that's why Cosmos only has 150 or 200 max number of validators. If you increase beyond that, the finality and just the consensus time goes very high.
But like how come Cosmos didn't change this, because they are like a relatively new chain, right?
So Tendermint, when this protocol was, so this proof of stake algorithm was suggested, it was best in class. We didn't know any better. PBFT algorithm, then Tendermint came. Vitalik worked on Casper, the friendly finality gadget. So over here, you do not have a, I think they don't have a predetermined leader schedule. Having a predetermined leader schedule just allows you to scale. So there are trade-offs.
No,
They do.
Uh,
They have
yeah.
Okay. Oh, so they ran each node. When does it happen?
I don't think they have a pre-selected schedule. I'm not sure, to be honest.
Yeah, I'm also not sure.
No, like look at the proposer node rotation part, right? They mention a new node is designated to propose the new block.
What does that mean?
Yeah, when? The question is when. Like Solana, pretty early.
Right, yeah. They don't have that prediction. Yes.
So usually in a distributed system, you have a leader selected till a leader goes down. What that allows you to do is you have some determinism in who the leader is, so messaging becomes easier. Like even if you look at draft consensus algorithm, you select a leader. Till the leader doesn't go down, you don't actually change the leader. Solana keeps on changing the validator after every block. So that's also helps in decentralization.
But that change is also predictable, right? That's why they can do that.
Yes.
Yeah, it is a DOS vector where you can say this
But-
guy is gonna kill them.
But like, why do they say that it's not good to be able to predict the leader?
DOS sector like hate set just right now. So if you know the leader, everyone can just bombard the next validator, and the validator can go down.
Okay. And the antidote to this is like what Jito is building, I guess.
Jito. So they have a proxy service in front that will just dump all the spam messages. So that will just protect the leader from going down, or the validator from going down.
Okay.
Even by the what the dedupe phase that essentially Firedancer is doing will help that, right? They just said that 1.2 million transactions, so messages coming in, they just dedupe them.
Yeah,
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 so
yeah,
there are
exactly.
mechanisms where, and also it can be censorship risk as well. So uh, it's like I don't like you, and you are sending me a transaction, and I know I run that RPC server, so I don't want your transaction to go in. So my RPC server will wait for the leader, which is like my friend, and we both will combine to censor you. But I think there are mechanisms to handle that. It's not that simple. Uh, but it's like it cannot be like you send a transaction and somebody can refuse to book it. That is flashable. So I'm not sure how does it work, but Ethereum folks constantly tell this it is a censorship risk.
But the filtering happens before it reaches the validator, right?
No, but
Yeah, so obviously RPC node can refuse you. Obviously, RPC node anyway are not part of the network, right? They just forward the transaction to the network. RPC nodes are just
Yeah, correct.
uh,
Yeah,
yeah. But let's assume RPC node does everything well. It colludes with a validator, which is my friend, and but I think this is not like it's not that simple, to be honest. There are mechanisms through which this can be handled.
got it, got
I
it.
don't buy the Ethereum folks say this is a censorship vector because with the new without the enshrined PBS, Ethereum also has a censorship vector because well,
Yeah,
blockchain just be
obviously.
overcommand, yeah.
Actually, they are not figured out how will they
Yes,
handle it. Like,
yes.
they have some CR list plan, but that is not matured enough. How does it work? And I think in Ethereum, like in Vitalik's last block, which was Endgame, he told that we will have block builders would be like centralized kind of a thing, and the verification can be decentralized. So that is obviously a censorship risk where there is only one person who's doing it. But so the CR list plan in PBS is like we will have a list prepared for the builder. Builder will be rotated, and verifier will be the one who will attest to it that okay, this block built by this one is right. Now in that CR list, there will be a list of addresses, kind of a thing, where they will say that verifiers who are like all the validators which Ethereum has 20,000 or I don't know, will say that okay, if you are the builder, you need to include this people from the list. If you don't, if you censor them, then we won't verify. So it gives the power to validators over the builder. Uh, it is proposed a builder separation, right? So uh, there are some. It is not matured. Like they have not still thought it out, like how this exactly will work. It is still very much thing in progress. Research is in progress, but there are risks for censorship with this.
Very interesting. Because I think your the builders if the builder is rotated then that makes it complicated because you want to select the builder which is giving you the most value. Uh, Rotating it kind of makes it a little moot because then you're not selecting the builder with the most value. But yeah, you're probably correct that they have to, the proposal needs to mature a little more.
Yeah, I think eventually there will be only like few builders. I don't think even with rotation, it's like Polygon only has three builders or something like that. Even I think
Let's,
that's why that's where Flashbots. I think all Flashbots will have this fat node, which will be the builder. Did it right now as well. So
I think they will
yeah,
just
anyways, Flashbot does 80% right now.
yeah, so eventually
But
there would be
Polygon is question.
yeah. Yeah. Polygon also has like I don't know very few builders. It has 100 validators. But, yeah.
Also, on a side note, Polygon uses this exact Tendermint for consensus.
Their consensus is so complicated. I never got across it. What are they doing? They have two
There are some
layers.
checkpointing, snapshot. Yeah, it's
Yeah, that is still fine, right? They are just committing to Ethereum and just check. But those are bunch of contracts on Ethereum, right? But how do they come to consensus is I'm still not like there is kind of soft consensus, there is hard consensus. There are two stages to it. I think it is this pre-commit and pre-vote and pre-commit, the two things which we saw over here.
They just
But
have a contract on Polygon and then it batches it to Ethereum, right?
uh,
Like how?
Polygon, it is its own chain by its nature. Like I would say, you can just stop the checkpointing and it can run as a Tendermint chain. Like with all this, we have so many Tendermint chains, right? So it does have checkpointing where it just periodically commits the state root to Ethereum, which is just a very naive contract. Uh, but that is fine. But how do they like? How does the Polygon chain itself work? How do they come to consensus or something like that? Uh, that is so complicated. I never understood. There are two layers, some Heimdall layer, and I don't know. And they use a fork of Tendermint or something like peppermint.
Yeah, I've not gone into that detail, but yeah, you're correct. Like, if Solana just tomorrow starts having a bridge contract which starts checkpointing to Ethereum, will you call Solana an L2? Is the question, because Polygon does the same.
Yeah, Polygon POS is not an entity. Yeah, there is no like uh, there is no trustness in the transaction which Polygon confirms, right? Whereas in case of you are generating a ZK proof of all the transactions and you are having that validity proof to verify from the Ethereum side. So yeah, Polygon POS is more like a side chain, to be honest. It's not a L2.
Actually, this was great here. I think you did a fabulous job of explaining everything. But this is all that they have covered in the video, right? I don't think they've covered anything more.
Yeah, just three things which we talked
Yeah.
about. And also important thing just to remember is we are at very early stage. Like the juicy part is still left. The banking stage which we talked about is still left, right? So and consensus which will come next. I think that's where like this two parts, runtime and consensus. That's where the fun will begin.
Uh, so can you go back to that previous image where you had those quick and Nick modules?
This one, or
I think there's another.
yeah,
Right. So that other image which you had, that's an expansion of dedupe and pack.
dedupe and sig verify. Uh, yeah,
Okay.
dedupe and sig verify type.
Okay. Okay. Got it. Got it. Yeah. Okay. I think that pretty much covers like whatever they had in the video.
Yeah.